Okay, so what we're going to build here is our test bed so we can test out our coils that we've made off of our coil machine and using the Vesper coil calculator. What you can see here in the middle is just a standard bearing. It's not anything special. It's just going to be used as a guide. You can see the outer profile here of where our rotor is going to go. And then you can see some holes here, and that's so that we can align a brace that's going to support our coils in the alignment once we get all of our coil parts and everything in place. What these are here is these are clamps that's going to hold down the front of our coils so that they don't move. We are going to support them from the back side, and that's what the threads on the end of the coil are for. And you can see that here in the threaded pattern that's in the back of the coils. That's why I left that spool, so that it actually had those coils on the back of it, and that's what you can see there. Okay, so we've got this unit here, and basically it's just going to have a clamp mechanism, and the disc of wood here is so that it's a spacer so that the clamp has something to brace against in the back of it, because we're going up a little bit high. And these have a friction grip on the inside, and then all you do is set it, clamp this little tab down, and it clamps the front of our coil down. Now that's pretty simple. We've got two of those that are going to go in. Those I've already pre-done, so it saves us a little bit of time on our build. It's very simple. Any type of little clamp will work. These are plastic, so that there is no metal that's going to be interfering with our test. That's very important when you're testing out. The only metal that's in the whole area is going to be this and the chuck for our drill press, and that's very far away. Now, this is our rotor, and as you can see, it's drilled for a couple of different size magnets, and that's so I can show you the differences in the magnetic face value of your magnets. Now, the magnets that I'm going to be using here are 1/2 inch. These are 3/4, and the Gauss rating from the 1/2 inch to the 3/4 is within about 200. So they are really, really close to the same, but they are a different size magnet, and that I'll show you a little bit later. What this composes of is basically the shaft that's been bolted through the fitting, and then as you can see here, I've set these so that I can pop those magnets back out. Now this bolt that's going through here is going to fit down inside of our little bearing, and again, it's just a standard bearing, nothing too special there. So how that fits is that'll go right inside of our bearing, so that as this rotates, it will rotate very freely. Now what we're testing on this test bed is the power coming off of our coil. We are not testing the rotation of the rotor. So what is going to rotate the rotor? That's going to come up to our drill press. Our drill press is going to clamp down onto it here through the chuck, and that's going to rotate our rotor. Now we know that the drill press is going to operate at certain speeds according to different belts, so we can regulate the speed of this to calculate out what the sizes and speeds are going to be and what the power rating is for our differences in speeds. It's a very calculated experiment. We know exactly how fast our drill press goes, so we always know how fast our rotor is going to go. And then we can play around with our coils. Different specs as far as how close the coils are, how far away the coils are. The placement of offset is also an issue. For this experiment right here, it's going to show our reference as far as our coil to our rotor. That our magnets are about 1 inch long. So that goes to show you how big our magnets are there. So they're 3/4 of an inch by 1 inch, 6,800. The Gauss rating on this is 6,800. So that's our starting width, and I'll go through that as we get further along in the build. All these holes were drilled on the drill press, and I've pre-done that to save us on our drill. And all they are is just pressed in, so they're very simple to go in. All of them are set so that it's the north-facing pull out, and I'll show you how to set those in another video. But that's to get us started on what our build is going to be for our coil test bed. These holes here are to bolt this down to the drill press, so that's going to be bolted down so that nothing is going to move. The bearing on the bottom is because of how much pull these each magnet pulls at about 35 pounds, so it's a lot of pull rating when you're dealing with these magnets. So we've got to make sure that that we've got these definitely secured, and that the bolt down here in where that it goes inside of this bearing. Helps to guide the bottom of this so that we get a nice even rotation of this. And I'll show you that as we get further along. It is kind of noisy as this is going around, but I'll show you all of that in another video. Okay, so what you can see here is I have been truing up the side of our rotor so that it's going to be perfectly round for when we're spinning this, so that there's no deviations. We're going to get a good clear reading. I'm going to turn that on. It's attached to the drill press, and I'm going to turn that on so that you can see that we are perfectly centered now. So there's no fluctuation, no movement. It's very, very centered, and it's relatively quiet. This is about how loud it's going to be when we get everything done. You can see where the holes are going in. It kind of makes it a little transparent, kind of a cool effect. But it's very, very centered and works very well. Okay, so I've went ahead and trued it up. I've got it all sanded and buffed so that it's ready for its coat of paint. And I went ahead, after I centered it, I went ahead and rebored our holes in here so that they were to the correct depth so that our magnets will be flush with the face. And you can see the punch out holes back here at the back. That's going to allow us to punch out our larger magnets. And if you look here really close, you'll see that little hole underneath this lip right here. See if I can zoom in just a little bit so you can see that. That little hole right there, if you watch over here, you'll see that that's our punch out hole for our small magnets. And so it's really important to be able to get our magnets out. Our next step is going to be to drill set screw holes that's going to go around here, and the set screw is what's going to hold our magnet in. So our next step was to cut our holes in the outside so that we can run our next step in, which is a set screw. And our set screw looks like this. It's an Allen screw. So on this side is an Allen. Bring it in just a little bit closer, maybe we can get a good look at that. But that's going to be the set screw that's going to go in the outside, and that's what's going to hold in all of our magnets. Okay, so what we have here is we have the set screws that are in place, and what they'll do is they will come inside here and make contact on our magnet. Show you from kind of this view here. You can see where they come through, and they'll make contact on the magnet to hold them in place. And then we'll just tighten those down with the Allen set screw. And that'll hold all of our magnets in place. We're only going to run one set of magnets at a time. So we'll run the 4 larger magnets, and then we'll run the 4 smaller magnets. So our next step is to finish getting this all sanded up and fresh coat of paint on it. Now that we're all centered, we've added the additions to modify this so that it'll hold the magnets in place. And we'll get everything set together and hopefully start testing some coils soon.